Welcome everyone. In this video, we will be learning about Kotlin Coroutine essentials, like what is CoroutineScope, CoroutineContext, job, dispatcher, and other things. For the prerequisite of this video, I want you to watch my previous video in which I have explained Coroutine what, how, and why. You can get that video from the description, so let's get started. So we have to start by creating a coroutine, and for that we have to use a coroutine builder. So launch is our first coroutine builder. So this launch is a coroutine builder with which we can start a new coroutine that does not return anything. It is generally used for fire and forgot tasks where we have to just run any long running task and forget about the result. Like here in this example, I am first printing this start and then I am launching a new coroutine, and inside that I am performing a 1 millisecond operation, 1000 millisecond operation, and after that coroutine completed, and outside of this coroutine I am printing end. So for the execution of a coroutine, you can consider it like this. Consider a normal function. So this main is a normal function. So first it will execute this line, then it will launch a new coroutine and forget about it. And then it will print this line and it ends. So this function ends, and it does not care what is inside of this launch function because that is a whole different scope and context. So it will first print this, then it will execute this. That means our coroutine will be launched, then it prints this, and then it ends. So if we are running this, then it should only print start and end, and that is it. So how should we make this print these two lines also? So I will do one thing. I will also use another coroutine builder. So this run blocking is our another coroutine builder, and I will copy this thing, paste it here, and after this end I will use delay of 2000 millisecond. So what will happen now? It will run this coroutine run blocking, then first it prints this start, then it launches a new coroutine, then it print ends, and then it will wait for 2000 milliseconds. So in this run blocking, we are now waiting for 2000 milliseconds. But parallelly inside of this launch coroutine, we are again waiting for 1000 milliseconds. And after 1000 millisecond is completed, with inside of this launch, we will print this, and after 1000 more milliseconds, so this ends. And let me print here. I will print run blocking ends. If we are running this, then it should print start, stop, start, end, coroutine completed, run blocking ends. We can also try doing this and it will still return us the same behavior because run blocking will block the whole thread, and after this run blocking is completed, only then we will execute further code. So it should print the same result, start and coroutine completed, and after this line is completed, only then this run blocking will be considered as completed, and then we will print run blocking ends. But there is one problem here. We know that we are using here 1000 millisecond, but in your original code, you will be not using this delay. You will be either making an API call or any database query. So you don't know for how much time this launch will take to complete our operation. So we cannot just randomly use 2000 or 3000 millisecond delay. So what we have to do is we will remove this. We will get here a job object. So just remember this thing. Launch coroutine builder returns as a job object. I will explain you what it is, but you can just use this job dot join. With this, you can wait for this job to be completed. That means when this launch function is completed, the execution, only then we will continue from this line. So that means it will suspend the block, suspend the function here, and only after this job is completed, then we will move ahead to this end. So you can also hover over this job and you will see suspend the coroutine until the job is completed. You can just see start, then we will wait 1 second, coroutine completed, and then instantly we will call end. So I hope now you understood what is this launch. After this launch, next coroutine builder is async. The async coroutine builder is used to return us a result, and the result is a deferred job object. You can see deferred of type T. What is this type T? So T will be the return value. So if I am passing here 1, so then this job object will be deferred of type int. So you can use this coroutine builder to create any coroutine which will return us a result after some time. So suppose after 1000 milliseconds, there are some calculations that we are doing, and after that we will return a result. And here this join will not return us a result, but await will. So you can hover over this await and you can see it is returning this type T, which is in our case an integer value. You can also read here, awaits for completion of this value without blocking a thread and resumes when deferred computation is completed, returning the result. So here we can get the result equal to job.await. So you can see this await is also a suspending function, and the previous join is also a suspending function. And because I am inside of my run blocking, only because of that I am able to use this join and await. If you are in a normal function, suppose here, then you can still use this launch, global scope.launch. I am creating a new coroutine here, but here if I am creating a job object, after that I will be not able to do this job.join, because that is obviously not inside of a coroutine. So I hope this makes sense. And let me print here result. So at this point I am damn sure that I will definitely get the result out of my async coroutine. And let me run. So I will print end with, okay, it is unit here because we are using join here. We should use await. Await will return us a result, but join will not return us a result. So coroutine ended, and with 1 and run blocking ends. So these are the main coroutine builders that you will be using. But the other important thing that you can observe here is global scope. What is this global scope? So it is a type of coroutine scope. You can consider a coroutine scope like a mother. So like a mother takes care of their children, this coroutine scope will take care of every children they are creating. So if I am doing this, well, scope equal to global scope, then I can use the scope to create multiple coroutines, like here scope dot async, and here also scope. So you can see with one scope I am creating multiple coroutines. And suppose if I want to cancel all the coroutines that are running under this scope, then I can call scope dot cancel here, and that will cancel all these 3 coroutines. You can use these scopes separately in any layer of your application, like in view model layer in Android. We have this view model scope, and in main activity. So let me show you here. So we will have here access to lifecycle scope. So this will be attached to a lifecycle of our activity, and for a view model, it will be attached to a lifecycle of our view model. So you can manage all the coroutines, you can start them, cancel them with the help of this coroutine scope object. So how to create a custom coroutine scope object? You can use this, and it takes a coroutine context as a parameter. So next topic is, what is a coroutine context? So this coroutine context is an interface that represents as a context of execution for our coroutines. It provides us with a set of elements that defines the behavior of our coroutine. So there can be different behaviors for our coroutines, like which thread pool it will be running on, what should happen on cancellation of a coroutine, how we will handle concurrency with our coroutine. So all these behaviors will be managed with this coroutine context. And how we can get this coroutine context object? So this coroutine context object will be made of 4 items, and that are a job object, a coroutine dispatcher object, so dispatcher dot default, coroutine name, and our coroutine exception handler, like here. Okay, so adding all these things up will make us a coroutine context object. So now we can pass this context inside of our coroutine scope. And also you can directly pass this thing also. You can also pass any of these value here directly. So suppose I am passing this default here, like this. That will also create us a coroutine context object at the end. So let me revert this thing here, and let me explain you all these 4 one by one. So first is this job object. You can consider this job as the handle to our coroutine, and this job in the coroutine context represents the coroutine itself. And every coroutine that you are creating, either with this launch or async, so it will return as a job object. So this job object is directly defining our coroutines, and a coroutine can have multiple states. So these states can be also accessed by this job object. You can go to the implementation and see here, it creates a job object in an active state. And by default, you have to also know that if we are creating any child coroutine with this job, so you can see a failure of any child of this job immediately causes the job to fail too. That means if we are having this launch coroutine, and inside this launch I am creating another coroutine, so this coroutine is the child of this above coroutine. if this children is failing, if this children is throwing any exception due to any reason, then this job will also fail. And optionally you can use this supervisor job object. So supervisor job, we have this object that we can use to independently manage our children coroutines failures. Also, as I said, we can access the coroutine states with using this job object. So here is my job object, and let me find. So inside this job object we are having different fields. You can see is active, is completed, and is cancelled. So if a coroutine is newly created, then all these three will be false. Let me show you something. So if the state is new, then all these three fields will be false. If the state is active, then is active is true. If state is completing state, then is active is true, but it is not completing yet. If it is in cancelling state, that we know the coroutine will be cancelled, so is cancelled will be true. And cancelled state, obviously it is completed and it is cancelled, so both will be true. And if it is in completed state, then only is complete is true, and both of them will be false. So I hope now you understood all these states. These are pretty obvious if you are familiar with these three possible states of a coroutine: is active, is completed, and is cancelled. So you can guess which one will be true and which one will be false according to these given 6 states. So using this launch coroutine, we are having a normal job object that we just saw here, and with this async we are having a deferred job object, which is a job object that returns us a result. And I already told you about this supervisor job object that handles the cancellation of children separately, or we can say independently. Here we have another job object that is completable job. There you can see we cannot directly create an object of this completable job object, but if you hover over this, you can directly see a job that can be directly completed using complete function. So you should just know that this thing also exists here. And after this job, we are having these dispatchers. So what is a dispatcher? According to the dictionary term, a person who is responsible for sending people or vehicle at the position, at the place where they are required. In Kotlin, this dispatcher also does the similar kind of work, because it will dispatch the current coroutine to the thread where it is required. So dispatcher.default, which is normally used for CPU intensive operation. We are also having dispatcher.io, which are obviously for IO operation. Then we also are having main and at last unconfined. So this is not a very small topic that we can cover in this video. It will need another separate video for it, and I will be creating one. So make sure to subscribe. And then we are having coroutine name, that is just for better testing purpose. And then we are having coroutine exception handler, that is used to handle the exceptions which may be not caught by the default handler. Also, you need to know whenever you are creating a new coroutine, so the default dispatcher will be here. You can see it will be dispatchers.default will be used. And also, if you are creating any child coroutine, suppose I am creating a launch here, so it will take the context of our parent coroutine. But here, if you are providing any other things, like for this coroutine I have to pass IO, so it will just replace this dispatcher for my child coroutine and take other things from my parent coroutine context. Also, the job object that will be returned by this coroutine will be independent and will not be similar to the parent's job object. So I hope now you understand all the things that are required for you to start with coroutines. If yes, then make sure to like the video, subscribe to the channel, and access the Android interview playlist from the description.